Okay, so in this lesson, we're going to look at counting problems. And in counting problems, one of the major goals is to determine the number of ways that something could happen. And the reason why we use counting problems is because we can then answer probability questions using those total numbers. So a basic problem would be that if you go to Chipotle and they give you a choice for your burrito, you could get flour or wheat tortilla, one of 3 types of rice, one of 5 proteins, and one of 2 types of beans. And I ask you how many burritos can be made with this deal. So you could certainly list all of the different burritos that could be made with this deal, but since I'm only asking you how many, I'd be more so curious that you tell me how many total burritos can be made. So the fundamental counting principle kind of tells us that if we can list the number of ways that each thing could happen, if we could assign a number to the number of ways each thing could happen, and all of these things are happening together, you're choosing a tortilla, you're choosing a rice, and you're choosing a protein, and you're choosing a bean, then we would just multiply all of those numbers. So we are starting by choosing a tortilla, and then afterwards we choose a type of rice, and then afterwards we choose a protein, and then afterwards we choose a type of bean. Now, we have 2 different types of tortillas that we could choose from, so that 2 is going to go there to represent that it could be either white or flour. As far as rice goes, we have 3 different types of rice. As far as protein goes now, there are 5 different types of protein. And as far as beans go, there are 2 types of beans. So I'm going to multiply those together and I'm going to get 60. So there are really 60 different proteins that can be made. Now a follow-up question might be, if a tortilla is chosen at random to be put on like an extra special deal, what's the probability of protein used is chicken? So I would first want to find the number of burritos that are made with chicken. So I'm still going to have these 4 dashes here. Oops. Okay. And there are 2 different types of tortillas. There are 3 different types of rice. But now, under protein, there's only really 1 type of protein. Chicken. That is the protein that I am choosing. And then there are 2 types of beans. So how many types of, or how many burritos have chicken in them? Well, that would be 12. So if I ask you the probability that the burrito is a chicken burrito, well, that would be 12 burritos out of 60 total burritos, which is 1/5, or 0.2. So either of those answers would be appropriate. Okay? Similar problem, but a little different. You're seating 10 students in a class with 18 desks, and how many ways can you seat the children? So with these counting problems, when I'm asking you how many ways can you do something, it's always best that you list out the dashes. So I'm going to list out some dashes, but I need to think about, what does each dash represent? Does each dash represent the child or the seat number? Now, if the dash represents the seat number, I have kind of an issue. Let's say that this dash represents seat 1. Well, I could ask how many different children could sit there. But one of the options could be no one sits there. That's going to make this problem really confusing. It would be much easier to have each dash represent the student number. So this is student 1. And then this would be student 2, 3, 4, 5, 6, 7, 8, 9, 10. And the question asked is, how many different places can this student sit? Well, that would be 18, and then 17, and then 16, and then 15. And why is there one less? Because one of those seats has been chosen each time. So there is now a student occupying one of those seats, so there is one less seat to be selected. 13, 12, 11, 10, 9. Now I'm going to have to multiply all of those numbers together, and I have a feeling that this is going to be a pretty high number. So there's a chance that I may have to write the answer in scientific notation. But let's take a look and see what it is. So I do have to write in scientific notation. It's 1.59 times 10 to the 11th power. So that's a lot of different seating arrangements. Now, let's suppose for a second that I want student 1 in a specific seat. So student 1 might be a troublemaker, I guess, and I want to sit him or her right up front. I want to make sure that I'm always watching what they're doing. So I might say that student 1 has to sit in a certain seat. Well, now, student 2 can sit in any of 17 seats remaining, student 3, student 4, student 5, etc. So I would then fill out all the other seats in that same way. Okay?